Hello, teenagers. This is Mr. Williams, and uh, this video is a little different than some of the others. This is not because I'm absent. I'm not going to be absent. But this video is just for me to work out some problems from the night book. So in our class, we use the college physics textbook by Knight, Jones, and Field. And it looks like this. So College Physics, A Strategic Approach by Knight, Jones, and Field. This is what we're using. And today, I'm going to go over with you on page 59, problems number 27 to 31. So I'm going to try to do this expeditiously, and you can pause and review at your own leisure at home. So let's take a look at these problems. First, page 59. Number 27. Here's what it says. What constant acceleration in SI units must a car have to go from 0 to 60 miles per hour in 60 seconds? So there's a lot of stuff here. First of all, mph means miles per hour. In physics, mi is miles. M is meters. So mi is miles and m is meters. So mph would be miles per hour. That's the first little thing I'll tell you. So this is what we're working on today, and I'm just writing all over the place here. Part A. The second thing I'm going to tell you is whenever we do problems in kinematics, my strategy for you is you should write down all of your kinematic variables. So there are 5 of them, and the 5 kinematic variables are v initial, v final, distance, time, and acceleration. And all of them will either be something that is given to us in the problem and it is therefore known to us, or it will not be given in the problem and it will be unknown. And you may have more than one unknown, but one of your unknowns is what the problem is asking you to solve for. And I want to identify all those things. So this tells us that the car goes from 0. So its initial velocity is 0 meters per second. Notice that it says in SI units. SI is, it stands for the French words Système International. Système International, the international system. These are base 10 units. Scientific notation, not notation, but meters, kilograms, seconds. Those are SI units. They're base 10. Unlike pounds and feet, which are not base 10. I don't know if I said that right, but whatever. Hopefully you get the idea. SI units, some other teacher should have taught you that, and I'm not messing around with it. So SI units are meters per second. The final velocity is 60 miles per hour. Well, you see a problem right there. It says in Système International units, and miles per hour is not SI, so we're going to have to convert it. I want to get miles to kilometers. Actually, I don't want kilometers. I want meters, but I know miles to kilometers, so then I'm going to get kilometers to meters. And then I need hours to seconds. You should have memorized that 1 mile is 1.6 kilometers. If you don't have that memorized, you should. And then I gave you a handout that showed you the conversions associated with each prefix in scientific notation. So kilo is 1,000. So for every 1 meter, there's 1,000. Oops, that's wrong. For every 1 kilometer, there's 1,000 meters. And this one I'm going to kind of do in my head, but you can do it out if you need to. How many seconds are there in a minute? There's 60. How many minutes are there in an hour? There are 60. Therefore, the number of seconds in an hour is 60 times 60. So 1 hour is 60 times 60. Well, 6 times 6 is 36. And then, so that must be 3,600. So there's 3,600 seconds. So let's bust out our calculators and plug this in. 60 times 1.6 times 1,000 divided by 3,600. And that's 26.7 meters per second. 26.7 meters per second. So my initial velocity is 0, my final velocity is 26.7 meters per second. Let's go back to the problem. We know the time. The time is 10 seconds. It says what constant acceleration. So I don't know the acceleration. I'm going to put a question mark beside it. I'm going to circle it because that's what the question is asking for. I do not know the distance. But it also didn't ask me to find the distance. Not yet. For part A. So that's the first thing that I do is I write down all my kinematic variables, what I know and what I don't know. I know VI, I know VF, I convert if required, and it is required here to get it into SI units. I don't know X, but I also don't care about X for part A. I know about T, and I don't know about A, but I want to know about A. Then I write down my kinematic equations. So that's my first step. Second step is write down my kinematic equations and pick through them. My kinematic equations are delta x equals 1/2 at squared plus v initial times time. And then I have vf squared minus vi squared is equal to 2ax. And then I have the definition of acceleration. And a lot of people will fart around with this and rearrange it. So you may see it rearranged in your book as something like, let's say, VF plus A delta T is equal to VI. I'm sorry, VF minus VI. That makes this VI. Yeah, I honestly do not memorize this. I just remember the definition of acceleration, which is VF minus VI over delta T, and then you can rearrange it to find whatever the heck you need here. There are teachers who will make you memorize this as though it were a brand new equation, and that's not me. I don't do that. If you know this, you can rearrange it to find, like if you have TF or TI or VF or VI, you can just rearrange this using your algebra skills. So let's look through here. We need to find A. A is in this equation, A is in this equation, A is in this equation. Good, it's in all the equations. I don't have X. So if I don't have X, this one is out. I'm looking for A, and I don't have, let's see, I don't have X, I don't have A, that's two unknowns. Well, then this will be the easy one for me down here, because I have VF and VI and T. And I'm looking for A, so I can just use this equation. So my first step, I write down my 5 kinematic variables. My second step, I write down my kinematic equations and sort through them and find which one is going to work for me. This one looks good. So then next step, I use my friendly equation. A is equal to VF minus VI over delta T. Remember, delta just means change in, and change is final minus initial, so TF minus TI. So my final velocity from up above here is 27.6. Oh, 26.7, sorry. 26.7 meters per second. My initial velocity is 0 meters per second. I'm going to divide by my final time. Well, if I start the clock at the beginning, my final time is 10 seconds. Minus my initial time, well, your time at the beginning is 0 seconds. So that's 27.6 divided by 10, and meters per second divided by seconds. So that is going to be 2.67 meters per second squared. And that's the answer to part A. Let's move on to part B. Since this is a multi-part problem, I'm not going to rewrite all of the kinematic variables. They're already up here. And I can also now use my answer from part A in part B. So for part B, I now have VI, VF, TA. The only thing I'm missing is X. Let's see what they ask for in part B. Part B says, what fraction of G is this? Oh, they're not even asking for A. They're asking for what fraction of G is this. So this particular question is just asking you if you know how to read math. And some of you do and some of you don't, depending on the type of teacher you had in earlier grades. So hopefully you had a teacher who taught you how to read math. Remember that the word is means equals and of means multiplication. So what fraction? So that tells you you're looking for a variable. What fraction? I'm just going to use X, even though X can be confusing in physics. X usually means distance. I'm not going to use X for distance. I'm going to use X for my unknown variable. What fraction? I'm going to call what fraction X. X multiplied by G, because the word of means multiplied. So X times G. Is means equals to. This, what is this referring to? What fraction of G is this? What is this? Well, this is referring back to the answer from part A. What was the answer from part A? It was 2.67 meters per second squared. 2.67 meters per second squared. So I'm solving for X, and I've got X is equal to 2.67 meters per second squared over G. Well, what is G? I did not tell you what G was yesterday. But if you just turn back in the night book 1 page, 2 pages for the summary of the chapter, just back 2 pages, and you look, it tells you right there, this is on page 55, that G is 9.8 meters per second squared. And you can also look back in the chapter by turning back 3 more pages to page 50. And in a yellow box, it tells you that well, just below this yellow box, it tells you G is 9.8 meters per second squared. So that's easily found in your book, even though we have not really talked much about G in this class so far, but it's easy to find. And you're an AP Physics student, so I would expect that you can use your own brain. So then let's plug in 9.8 here. 2.67 meters per second squared over 9.8 meters per second squared. I have meters per second squared in the top and the bottom, so they both cancel out. I take my handy dandy calculator, and I say 2.67 divided by 9.8. And I get 0.27. So you could write that a couple ways. You could say it's 27%. You could say it's 0.27. You could say it's 27 over 100. So these are three ways that I personally would accept that answer. It asks you, what fraction of G is this? It's 0.27 or 27% or 27 over 100. Mathematically, those are all identical. Okay, let's look at the next part of this question. That's part C. Part C is, how far has the car traveled when it reaches 60 miles per hour? Give your answer both in SI units and in feet. All right. I'm going to shift my page up just a little bit here. And let's do part C. So I will remind you, looking back up here, that you have VI, VF, T, A. A is this, 2.67 meters per second squared. And we don't know distance. And these are our kinematic equations. I need distance, and I've got everything else. Well, this one doesn't have distance in it. I guess I should rewrite them just so you can see my process, because I rewrite them all the time. Delta x is equal to 1/2 a t squared plus v initial times time. Vf squared minus vi squared is equal to 2ax. And a is equal to vf minus vi over delta t. I am looking for x. X is not in this equation, so that's out. X is in this equation, and x is in this equation. So either one of them would work. It doesn't matter which one I choose. And I, Mr. Williams, I like this equation. This is my favorite equation for kinematics. I just think it is awesome, handy dandy, and sweet. And because I like it so much, that's the one I'm going to use. But you could use this one, and you'd get the same answer. So let's use this one, delta x. I'm just going to put this little box over here. So that's my reasoning for how I choose my equation. Delta x is equal to 1/2 a t squared plus v initial times time. I always rewrite it when I get started with my work. My initial velocity, if you pull down here, my initial velocity is 0. That is so nifty. Because my initial velocity is 0, this whole thing becomes 0 because 0 times time, 0 times anything is 0, so that's gone. I want to know how far I go. So the change in my distance is equal to 1/2 times, and from up here my acceleration is 2.67 meters per second squared. 2.67 meters per second squared times the time was 10 seconds, and that's going to be squared. So 10 times 10 is 100, half of that is 50, 50 times 2 is 100 plus the 50 times 0.67. So that's going to be like 100. I should just do it. 0.5 times 2.67 times 10 times 10. It's 133.5. So that's 133.5 meters. And that is the answer in meters. But they also ask you to find the answer in feet. So let's convert. 133.5 meters. I need to go meters to kilometers. Kilometers to miles. And miles to feet. The reason I did it that way is you should have this memorized. 1 kilometer is 1,000 meters. You should have this memorized. 1 mile is 1.6 kilometers. And you should have this memorized. 1 mile is 5,280 feet. If you don't have those memorized, you need to memorize them. 1 mile is 1.6 kilometers, and 1 mile is also 5,280 feet. So make yourself a note of that if you don't know that and get it memorized. Now let's plug all this into my calculator. So 133.5 times 5280, I'm multiplying the top across, divided by, now y'all mess up on this, so I'm just going to say this, please pay attention. You see that I got two things in the denominator multiplied, 1,000 times 1.6. If you type in 1,000 times 1.6, you're going to get the wrong answer. You have to put the stuff that's in the denominator in parentheses. If you type in 1,000 times 1.6, your calculator thinks you want to take the numerator, divide it by 1,000, and then when you're done dividing by 1,000, multiply that entire answer by 1.6. That's not what we want. We do not want that. We want the numerator divided by the denominator multiplied together. So you need to put open parentheses, 1,000 multiplied by 1.6, close parentheses. This forces your calculator to do the multiplication in the bottom before it divides the top by the bottom. And that's a good thing. All right, so that is 440.6 feet. So those are the two answers required for problem number 27. Let's move on to number 28. All right, let's look over here and see what it says. Number 28, when jumping, you know what, I need a pencil sharpener. Give me just a second. My pencil is getting all crummy. Okay, when jumping, let's see here. A flea rapidly extends its legs, reaching a takeoff speed of 1 meter per second over a distance of 0.5 millimeters. All right, we're going to have to draw a picture here before I even get down to parts A and B. So I'm going to draw a little, so here's the ground right here. And I'm warning y'all, I can't draw worth a hill of beans, so you're just going to have to put up with my terrible drawings. My flea starts out with bent knees. God, how do you even draw? That's my flea. Here's my flea. Yay, he's fleeing. All right, bad joke. There he is with his little bent knees. Before. My pencil. This is not cooperating. Let me get another pencil. Yeah, that was a waste of time. So this is before, and this is after. My flea is going to fully extend his legs. And there's going to be a change in the height of his body. So if this is like the height of his body here, and this is the height of his body here, then this distance here is going to be D equals, they tell you it's 0.5 millimeters. 0.5 millimeters. So that's my picture to help me kind of understand what's going on in this problem. What do I know? I know that the distance is 0.5 millimeters. Well, I don't want millimeters, I want meters. So 1 meter is 1,000 millimeters. So hold on, my email. that's not important. Okay, so 5 times 10 to the negative fourth meters, because see, it's got 3 decimals, so you go back 3, 1, 2, 3. Or you could think of this as 5 times 10 to the negative 1 meter, and then you're going to go backwards 3 because of the 3 zeros. So negative 1 minus 3 is negative 4. Whatever. You guys should be able to do this. That's distance. What is my initial velocity? Well, my initial velocity is 0 meters per second. And the problem says, so VI is 0 meters per second, and VF is 1 meter per second. Acceleration is unknown, and time is unknown. And part A asks me to find his acceleration, because part A here says, what is the flea's acceleration as it extends its legs? How long does it, and part B is, how long does it take the flea to leave the ground after it begins pushing off? The bell just gave me the 10-minute warning, so I'm going to try to finish this up, and then I'll make you another video when I get home tonight for the other problems. So part A here, let me write down my kinematic equations. My kinematic equations say delta x is equal to 1/2 at squared plus v initial times time, and vf squared minus vi squared is equal to 2ax, and a is equal to delta v over delta t. I want a. I could use any of these. I don't have time. So since I don't have time, I can't do that. I can't do that. So that leaves this as my only viable option. So that's how I pick my equation. Part A, it asks A. Let's go here. Vf squared minus vi squared is equal to 2ax. I want to solve for A. I divide both sides by 2 and x. So A must be equal to Vf squared minus Vi squared over 2A. I plug in my numbers. You guys should be able to do this algebra because this is an AP class and you should know algebra before you come in here. So if you look back up here, Vf is 1 meter per second and Vi is 0 meters per second. And that's over 2 times my, oh, wait a second. We know x. I should not have solved, I solved for a, I should have solved for x. So this would be, I'm a little nervous because the bell's about to ring and I keep getting emails. So this should be, yeah, this is right. So then a, were we solving for x or a? Oh, we're solving, shoot. There, that should be fine. This is 1 meter. Is it 1 meter? No. It's 5 times 10 to the negative 4th meters. 5 times 10 to the negative 4th meters. I plug this into my calculator. 1 divided by, you have to put parentheses around everything in the denominator. Please do not forget that. Because kids are going to want to type in 1 divided by 2 times 10 to the negative 4th. No, you have to type in 1 divided by parentheses 2 times 5 times 10 to the negative 4th. And it should look like this on your calculator. That little tiny e means times 10 to the. That's what it means. So then you get 1,000. 1000 meters per second squared. That is the answer to part A. And then part B, what does that ask you? How long does it take? So let's go back up to our equations. Vf squared minus Vi squared is equal to 2ax, and delta x is equal to 1/2 at squared plus v initial times time, and a is equal to delta v over delta t. I now know everything except t. So this doesn't have t in it. That is no good for me. I could use either one of these. Either one is fine. Doesn't matter which one you use. I personally like this one, so I'm going to use this one just because I like it. So there you go. So here we go. Delta x is equal to 1/2 at squared plus v initial times time. My initial velocity is 0. Anything times 0 is 0, so that goes away. I want time, so I've got delta x is equal to 1/2 at squared. You can do I could do the algebra in my head, but I'll be nice to you. Multiply both sides by 2, you get 2 delta x. Then you do, well, I'm doing it in my head anyhow. Then you divide by a, and then you get, that's going to be equal to t squared. So I need t, so I'm going to take the square root of both sides, and you get t. Let's plug in the numbers. If you didn't follow, slow down the video and watch it carefully. Delta x is 5 times 10 to the negative 4th meters. And a, which we just found in the previous one, is 1,000 meters per second squared. So if you plug this in, second, square root 2 times 5 second EE negative 4 divided by 1,000 close parentheses, that is 0.001. And that's the answer for part B. Okay, that's all the time I have for this particular video. Sometime this evening, I will make a video for 29, 30, and 31. All right, thanks.